Hey guys, in this lesson we're going to be covering conditional logic, all right? That's these if-then statements you see popping up a lot. We're going to talk about what conditional logic actually is. After that, we're going to get into sufficient and necessary conditions, which are really the bread and butter of conditional reasoning, all right? Then we're going to talk about contrapositives and see how they are used to chain together statements and screw with your logical reasoning and logic game scores. Next, we'll take a look at common conditional logic errors, aka how are you guys screwing this up and how can we get you to stop screwing it up, all right? We want to get familiar then with logical indicators, which we actually have a whole separate video lesson on, but we're going to take a look at them here anyways. And last but most importantly, we're going to work some practice problems so you guys see how to practically get some points out of this lesson. So why is this lesson important, all right? What are we supposed to get out of this lesson? Conditional logic is found on roughly 20% of the LR section. But a lot of times when I look at my students' scores, a lot of their problems in logical reasoning and logic games can actually be fixed by a better knowledge of conditional logic. All right, now I want to address that real quick because I'm sure you guys are getting excited thinking I'm going to teach you how to diagram and you're going to want, become some kind of LSAT god. Wrong. In fact, I think actually a lot of my students have left conditional logic lessons and gone to do a practice test and actually scored worse on logical reasoning. So how's that work? All right, this lesson emphasizes diagramming a lot, like a lot, guys. So what happens is you watch this lesson, you see how to recognize these statements, and boom, you just go and diagram everything. Bad students. You need a balance. All right, not everything needs to be diagrammed. The logical reasoning section is not logic games. I'm going to say it again. Not everything needs to be diagrammed. But at the very least, it needs to be recognized. That conditional logic needs to be recognized. Okay, so this lesson, my goal is to make sure that you can, number one, recognize conditional logic. Number two, decide when to diagram. Number three, diagram correctly. And number four, bob and weave through the answer choices. First up, what is this conditional logic we're making all this fuss about? Well, here it is. So basically, conditional statements have this arrow. And the way we read them is this. If the thing to the left of the arrow is true, then we know for a certainty that the thing on the right is true. Right? If this is true, then this is definitely true. All right, so here we have a conditional statement. Paris, arrow, France. And we read it this way. If you are in Paris, then you are in France. Very simple. Anyone in Paris must be in France. All right, being in Paris implies you are in France. All of these things are different ways to say the exact same thing we had it there at the top. All right, so based off of those logical indicators, which we're going to cover later on in this lesson and also in a separate lesson, we have multiple ways to say the same thing. All right, so again, if the left side of this is true, then we definitely know that our statement to the right is true. Think about it. You can say without a shadow of a doubt that if you are in Paris, you are 100% in France. There is absolutely no way you can be in Paris without also being in France at the same time. All right, so these two guys here, our left side and our right side, they're what's called the sufficient and necessary conditions. And conditional logic is just the visual way that we describe the relationship between a sufficient and necessary condition. So now let's get into how these two guys interact. So what are sufficient and necessary conditions? We're going to start boring and put the definitions up on the board. Okay, so sufficient condition is defined as an event or an idea that when true indicates that the necessary condition must also occur. The necessary condition is defined as an event or idea that when true is required in order for the sufficient condition to also occur. Now I want you guys to notice, we define the sufficient condition based on how it affects the necessary condition. And we define the necessary condition based on, guess what? How it affects the sufficient condition. That's because these two guys are completely linked. You cannot have one without the other. That linking, that glue holding these two guys together, that's what conditional logic is. So if we put up a basic conditional logic statement, all right? If A, then B. Here is our sufficient condition. Here's our necessary condition. Always, it will be set up this way when you diagram it. But in your statement, you don't need your sufficient condition to show up first. Within a sentence, you can have either your sufficient or your necessary condition first. More on that later. We have a whole lesson on indicators that's going to cover that and clear that up for you if that confused you. Okay? I think the best way to look at these is actually almost like a logic games rule. Right? Conditional statements, they give us a rule. It says you have these two things, A and B. And it defines that rule. It tells us that if you have A, then because A is there, then B definitely has to be there. Going back to my example, if you are in Paris, then you are in France. Based off of this rule we have set up, we don't always have to be in Paris, right? All this tells us is that if you are in Paris, then you most definitely are in France. Now go in reverse. Think about this logically. If we are in France, can we definitely say that I'm in Paris? No, we definitely can't. All right, that's not a certainty. There are tons of other cities in France. So that's why our arrows point from left to right, and it's not just some line. There's directionality here. So what can we say about being in France? Well, remember our definition of the necessary condition, right? Our necessary condition is necessary for the sufficient condition to be possible. So what happens if we get rid of that necessary condition and we say, I'm not in France? Is it still possible to be in Paris? No, it's not. And that's why it's called the necessary condition, because it's necessary for your sufficient condition to be true. If you are in Paris, that's sufficient. That's enough to guarantee that you're in France. Being in France is necessary if you want to be in Paris. And that's kind of the basic relationship between the sufficient and necessary conditions. So to drive that point home, let's do another one and apply that same line of thinking to something a little bit more abstract maybe. We can say if Ariana is at the party, then Alex is at the party. Now pause this video, write down what is your sufficient condition and what's your necessary condition. All right, hopefully you guys got this right. The sufficient condition is Ariana is at the party. The necessary condition is Alex is at the party. Again, we're not saying with this rule that Ariana is definitely at the party. What we're saying is that if Ariana is there, then that's enough for us to conclude with certainty that Alex is most definitely there. Our sufficient condition, Ariana being there, guarantees the necessary condition that Alex is there. Can we say using our little rule that if Alex is at the party, then Ariana definitely is too? No, we can't. She can be, but she doesn't have to be. But what can we say? We can say that if Alex is not there, then Ariana definitely can't be there. Because according to our rule, if Ariana was there, Alex definitely would be too. So Ariana being there is sufficient to guarantee that Alex is there. Alex being there is necessary for Ariana to be there at all. But just because Alex is there doesn't mean Ariana has to be there. Just like being in France doesn't mean you're definitely in Paris. Now let's take a look at one more example, just kind of for good measure. I think you guys will like this one, and it's this. If you got a 180 on the LSAT, then you must have studied for it. Okay? Now, if we take that statement to be true, then we know without a shadow of a doubt that anyone who got a 180 on the LSAT must have definitely 100% studied for it. We can say that. Okay? Again, pause this video and think it out. Write down your sufficient and necessary conditions. So what's our sufficient condition? Getting a 180. What's our necessary condition? Studying for the LSAT. So we'll do this one more time, guys. All right, getting a 180 on the LSAT is sufficient. It is enough to guarantee that you studied for the LSAT. Okay, studying for the LSAT is necessary if you want to get a 180, but studying for the LSAT does not guarantee that you'll get a 180. Right? I think we can probably all agree on that. All right. So real quick here, what I'm going to do is I'm going to put up some keywords that let you know if you have either a sufficient condition or a necessary condition. All right, this is kind of a complex topic, these indicator words, and so we actually have a whole set of dedicated lessons for these. But just to be thorough, if you want to screenshot this list, even though it's not totally comprehensive, it will still be way more than enough to get you started with your indicator words here. All right, now that we've got kind of a grasp of what conditional logic is, let's get into that issue I was talking about earlier in the lesson. When to diagram and when to not diagram. Because you really don't want to overdo the diagramming here. All right, I'm going to begin this little discussion by saying that the vast majority of LR questions do not need to be diagrammed. It's just not necessary. Conditional logic puns, right? To get the questions right. It's not necessary to get the questions right. So here, I'll tell you what I do. I only choose to diagram conditional logic when I feel like it's going to help me organize the information that I have in my stimulus. If I leave something, a stimulus, and I say, what the hell did I just read? But I can recognize the logical indicators within the stimulus, I'll fall back on my ability to diagram. I'll fall back on that structure. Okay? The diagram is just a nice way to take a set of statements that can be really complex and make it easier to understand. Now, what kind of person should be diagramming all the time? Two groups of people. People who are really visual-based learners and people who have bad short-term memories. All right, these diagrams are great if you are struggling to remember what was said, because it gets that, kind of complex relationship and it smushes it down into a couple of letters and an arrow. All right, but if you're doing that, you have to make sure that your knowledge of sufficient and necessary conditions is absolutely concrete. All right, now also remember, guys, on your test day, you can't draw on the screen. You are forced to diagram on scratch paper. And I would really get into the habit of just practicing that. Whenever you work conditional logic problems, do it out on a separate piece of scratch paper and keep it organized. That organization is key on test day to making sure you don't make any stupid mistakes. All right? We don't want to lose any stupid points. Next up, I want to add in one little small detail regarding sufficient and necessary conditions, and it's this. Our sufficient condition does not make our necessary condition occur. If we go back to that last example that I just used, if you got a 180 on the LSAT, then you studied for the exam, okay? I think a lot of people mistakenly look at conditional logic as sort of a causal setup, where you have, the sufficient condition being the trigger, and then the necessary condition being the outcome. That is wrong, 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 wrong. You can't look at it that way, because while that's true sometimes, such as in the example where Ariana was at the party, then I was at the party, it's not true with all examples, such as our 180 on the LSAT one, because getting a 180 on the LSAT didn't cause you to study. In fact, here our sufficient condition is actually the effect of studying. So if you were looking at this as a causal setup, you'd get this dead wrong. All right, say I change how my statement is worded. Anyone who got a 180 on the LSAT must have studied. If you're looking at conditional logic as causal and ignoring the logical indicators, then it's super easy to screw it up and diagram it this way. If studying, then 180. But that's totally wrong, and it's just illogical. That statement is then saying that if you studied for the LSAT, then with certainty, we can guarantee you'll get a 180? That doesn't make any sense, right? I have no job, right? Conditional logic is not causation. We have a whole separate lesson on causation, and it's so important for you to be able to tell the difference here. To kind of wrap up this section, I cannot stress enough to you guys how important the sufficient and necessary conditions are on this test. I know everyone hates running drills, but really it's so damn important, guys, to be able to quickly and efficiently recognize and diagram out your sufficient and necessary conditions. All right, so now we're about halfway through this lesson, and we're much smarter than we were before. All right, let's turn up that heat. I'm going to give you my original example and then give you 4 statements to take a look at for you to decide if they fit within the rule established or if they don't. So pause this video after I give you your 4 statements and decide, do these work? Do they fit within my rule? And then we'll come back and discuss them together, okay? So if you are in Paris, then you are in France. There's our example. Let's take a look at our 4 statements. Then you're going to pause the video, think them through, okay? Number 1, Alex is in Paris, so he must be in France. Number 2, Alex is not in Paris, so he must not be in France. Number 3, Alex is in France, so he must be in Paris. And number 4, Alex is not in France, so he must not be in Paris. Pause the video now. Do these guys work or do they not? All right, let's go through statement by statement and see which one is correct. All right, statement 1 is identical to my conditional rule, so it's correct, right? That fits. It's just rewording. I'm saying the same thing. All right. Statement 2 just negated both sides, and it doesn't make sense. Just because we're not in Paris doesn't mean we're not in France. We could be in Cannes or Nice or really anywhere else in France, right? Normandy. Statement 3 reverses our rule and says that if we're in France, then we can say with certainty that I'm in Paris, which again doesn't make sense. We could be somewhere else in France. Statement 4 is what we call the contrapositive. This is the meat of the lesson, guys. What we did was we flipped our sufficient and necessary condition and negated them. So let's take a look at our statement there and see if it's logical. If we're not in France, can we say with certainty that I'm not in Paris? Yes, we can, because being in France is necessary if we want to be in Paris. Okay? This logical setup is called the contrapositive. It's so useful on this test, and a ton of questions in both logical reasoning and logic games take advantage of the contrapositive. Essentially, what you do is you flip your sufficient and necessary conditions and then you negate them. So if we have our other statement, our other example, if you got a 180 on the LSAT, then you must have studied for it. We first flip and we get if you studied for the LSAT, then you got a 180. All right, don't stop there though. That's wrong. All right, we have to add another step. We have to negate. So if we negate now, it says if you didn't study for the LSAT, then you didn't get a 180. Okay, notice the didn't study and didn't get a 180. That's the negation. That final statement is our contrapositive, and it is a logical inference we can make based on our original conditional statement. You can do this with every single conditional statement you get. You can look at it like having your conditional statement coming in as a pair. All right, you've got 2, the original and the contrapositive. They're equivalent. So while we're here, we can see how this, how you diagram negatives. There are a few different ways people symbolically do it, and I'm going to show you two. If I have the statement, if I do not go to the store, then I won't have dinner. All right, obviously I'm very hungry when I wrote this lesson. We can diagram this two ways. If go to store, then have dinner, or if do not go to store, then do not have dinner. Personally, I kind of prefer my little squiggly line just because it's kind of faster. Maybe it's a little harder to intuitively understand what it's saying, but with practice, you definitely get used to it, all right? Negating these statements, it usually just involves adding a not where there wasn't one before, or removing a not if you had one there, okay? For example, the negation of Alex is not an American is going to be Alex is an American. I just got rid of my not. If you want to take the contrapositive of a negative, all right, so my original statement, then I have, if dinner, then I go to the store, all right? You just got rid of the negative, and that's it. So we've got a few practice problems up here for contrapositive practice. I want you guys to pause this video now and work them just to make sure we're all on the same page before we move on. Okay, guys, hopefully you got all of those right, all right? We're gonna talk about that last one where I said, if I get broccoli, then I won't get carrots. Okay, so the answer to that one you saw was, if I get carrots, then I won't get broccoli. I want you to think about what this is saying. We say, if I buy my broccoli, then I definitely won't buy carrots. All right, therefore we know that if I bought carrots, then I definitely didn't buy broccoli based off of my rule. Okay, so now let's take a look, a little bit of a review for the contrapositive side of this lesson. All right, so we've diagrammed, we've learned contrapositives. Now let's figure out how the hell we use these to get some points, okay? Two of the most common ways that the LSAT tests conditional logic is centered around two Harry Potter spell sounding things. It's modus ponens and modus tollens, okay? First up, we have modus ponens. I'm gonna give you the basic structure first, and then we'll get into an example, we'll be a little bit more practical with it, okay? Here's our abstract. Premise one says, if A, then B. Premise 2 says, okay, A, and then what's a good inference we can make off of that? B. All we're doing here is we're setting up a rule, saying we have our sufficient condition, and then concluding that our necessary condition must occur. Pretty easy. That's just the definition of conditional logic, okay? If we want to put that into action. If I get some vacation time, then I will go to Disney World. My boss just told me that I'm getting 2 weeks of vacation time. We diagram it out. If VT, then Disney World. Right? We say we have vacation time, therefore we're going to Disney World. All right, this isn't exactly rocket science, okay? Then we have modus tollens. So you saw that modus ponens dealt with affirming or agreeing, saying that we have our sufficient condition. Well, modus tollens is about denying our necessary condition. Spoiler alert, fellas, this one deals with the contrapositive, okay? So again, let's set it up in our simple abstract form. Premise 1 says, if A, then B. Premise 2 says, B, we have got B. What's the good inference we can conclude? We have A. Now we do an example. If I'm hungry, then I'll eat pie. I'm not eating pie right now. What can we conclude? I'm not hungry. Okay, we want to set up our conditional statement now. We want to see how this guy operates. If hungry, then eating pie. I'm not eating pie, therefore not hungry. How can we conclude that? Based on the contrapositive of our first premise, which is, if I'm not eating pie, then I'm not hungry. Again, this is not rocket science. It's really not that hard, okay? I would encourage you guys to take these inferences and diagrams off the page and really think about what each one of them really means. It'll just get you farther, okay? Now, the reason I say that is a lot of the time, people just rely way too much on conditional diagrams and completely forget to think, which is stupid, right? The LSAT is and always will be a critical reasoning test, not a test of how well you can diagram, and it is so important for you guys to remember that. With that said, in this section of the lesson, we're going to be taking a look at the types of mistakes people usually make when they're trying to make inferences with conditional logic. Okay, so we have a couple of bad inferences here. Let's see what we can do to make sure that you guys don't pick them. The first one is this. Negating the sufficient condition. That's bad. Don't do that. It's going to look like this. We have our abstract. Premise 1 says, if X, then Y. Premise 2 says, not X. What's the bad inference here? Not Y. Okay, so again, that's kind of abstract. Let's get kind of a real situation going. Premise 1 says, if Alex went to Whole Foods, then he spent too much money. Premise 2 says, Alex didn't go to Whole Foods. What's the bad inference? Alex didn't spend too much money. Like, really? Can we definitely conclude that I did not spend too much money? There's no other way I could have spent too much money than just shopping at Whole Foods? Okay? Remember, your sufficient condition is just enough to say that your necessary condition did occur, but not enough to say that anything didn't occur. That's the same thing as just negating your conditional, which we saw, like very early on in the lesson, you can't do. That's bad. We cannot do that. Okay, so we see here I've got like a pretty basic example, right? If x then y is not the same thing as if not x then not y. Okay? The second mistake that is made is this, accepting the necessary condition. Okay, so premise 1 says if x then y. Premise 2 says y. We've got y. What's a bad inference? X. Let's take a look at it in a sentence. Premise 1 says if Alex went to Whole Foods, then he spent too much money. Duh, right? It's the same as before. Premise 2 says Alex spent too much money. Bad inference, bad conclusion that we can't make. Alex went to Whole Foods. Again, all this did was reverse the necessary and sufficient condition. And this one is actually really, really common. You see it in a lot of flaw questions, a lot of weakened questions. You cannot just reverse your necessary and sufficient condition. If we diagram out our statement, premise 1 says if Alex went to Whole Foods, then he spent too much money. All right? Alex went to Whole Foods, then spent too much money. Premise 2 says we spent too much money. Bad inference, Alex went to Whole Foods. It's bad. So we're going to have a separate lesson on each of these elements, but just to get you guys through the problem set, we're going to take a look at them here. I'm going to do my best to make sure this is as easy as possible for you guys. Let's see if I succeed. Okay? First up, we have either or statements. Insert the groans and tears and the sweat of broken law school dreams with these, right? When they pop up in conditional logic, they really, really screw with you guys. Let's find out why here. Okay, we're going to take this example. I want either a pizza or a burrito. What does this mean to you guys? All right, well, in normal everyday life, this means I want either a pizza or I want a burrito, but not both. On the LSAT, that is bad logic. According to the test writers, when you see an either or statement, it just means we have at least one of them. So according to my test, I can have both pizza and a burrito. Yay, right? So how does that help us in conditional logic? Well, that definition of we have at least one of them tells us something, and it actually tells us something conditional. If we take a look at my example here of I will either have a pizza or a burrito for dinner, we can actually diagram it like this. If not pizza, then burrito. If not burrito, then pizza. Why can I get these statements? Because our statement, our original conditional statement, tells us that I need to have at least one of them. So if I don't have one of them, then I must have the other. So put into conditional terms, not having a pizza is sufficient to guarantee that I must have a burrito. That's about as far as we're going to get into that one, right? I'm going to save the rest of it for a more advanced, more advanced conditional logic lesson later on. Our next type, right, is only, if, and the only. So if you remember from our discussion of the sufficient and necessary indicators, only and only if are necessary condition indicators. Well, guys, they have a stupid cousin, and his name is the only. Let me give you an example. The only people who like Pepsi are idiots. All right, what do we do with this? Only here is still referring to the necessary condition, but you have to get a little bit back into the grammar. So what is only doing here? It's acting on the word people, and people is acting on the word idiots. So what can we guarantee here? Someone is an idiot. What do we need to guarantee that someone is an idiot? That they like Pepsi, because Pepsi is trash. So we have liking Pepsi being our sufficient condition, and being an idiot the necessary consequence. And our diagram looks like this. If you like Pepsi, then you're an idiot. All right? So I know that this is probably a hard conditional to see, and people really struggle with it, but what we can do to maybe make it a little bit easier is look at another example. The only way to get a 180 is to study. Okay, so here only is working on the word way. And what's the way? Studying. Studying is the way. So what can we guarantee? That someone studied. How can we guarantee it? If they got a 180. So our diagram is this. If you got a 180, then you studied. All right? That's a setup that a lot of students miss. So if you can see this, you're already way ahead of the curve in beating your competition to that law school seat. Last but not least, we have the fabled biconditionals. These are conditional statements that have multiple sufficient and or necessary conditions. So I've got an example. Let's get into it and take a look. To be a Navy SEAL, you have to have both mental endurance and physical strength. All right, so let's use that same momentum from the last example and ask ourselves, what can we guarantee? Look at it both ways. Can you guarantee that someone with mental endurance and physical strength will be a Navy SEAL? No, you can't. But if someone is a Navy SEAL, can we guarantee that they have both mental endurance and physical strength? Yes, you can. So there's our necessary condition. But we have two. All right, how do we diagram this? Super easily, right? If you're a Navy SEAL, then you have mental endurance and physical strength. But where things get kind of hairy is now we have an and in our necessary condition. All right, what do we do with the contrapositive of this? What do we do with the contrapositive with an and? Again, it's super simple. When you negate an and, it becomes an or. When you negate an or, it becomes an and. Let's think about that logically for a second. Our statement has set up the rule that every single Navy SEAL has mental endurance and physical strength. If we flip that statement and negate, we want to guarantee that someone can't be a Navy SEAL. Do they need to be missing both things? No, they just need to be missing one. All right, so if you are missing mental endurance or missing physical strength, then you cannot be a Navy SEAL. That is our correct negation, okay? So that's our conditional logic lesson, guys. We're gonna get into a little bit of a review for a second and then work some practice problems, but that should get you well on your way to mastering conditional logic, which is so important on this test.